Dear students, uh, we will continue with the previous topic, that is the sigmatropic rearrangements. In last few lectures we discussed the definition of sigmatropic rearrangements in detail. I gave you some examples also. We will deal with this topic in much more depth during the next half an hour maybe. So as I said that in a sigmatropic rearrangement in a sigmatropic rearrangement I said that a sigma bond is broken. A sigma bond is broken in the reactant. You know that in the reactant, and a new sigma bond is formed in the product and the pi bonds rearrange. The pi bonds rearrange, or they move from one location to another location. We have discussed this thing in previous lectures. Here I have to mention some points. That's why I repeated this definition once again. There are some very important points which you should note while studying sigmatropic rearrangements. Point number 1 is that the number of pi bonds in the reactant, and the product remain the same. Means जो नंबर ऑफ डबल बॉन्ड्स रिएक्टेंट में होंगे उतने ही नंबर ऑफ डबल बॉन्ड्स प्रोडक्ट में भी होंगे. Means there is no change in the number of pi bonds in the reactant as well as in the product. Point number 2. What is the second point? Second point is that the sigma bond that is broken can be in the middle of the pi system, means it can be in the middle of the molecule, or it can be at the end of the pi system. So 2 points are very important. One point is that the number of double bonds remain same in the reactant as well as in the product. Number 2, the sigma bond that is broken, it can be in the middle of the molecule, middle of the pi system, or it can be at the terminal end, or it can be at the end of the pi system. I will give you 2 examples, where in one example sigma bond is broken in the middle, and in another example sigma bond is broken at the periphery. So let me take the first example where sigma bond is broken in the middle. I will take this example. This is the example. You have CH3 here. You have a double bond here, and you have a double bond here. So what happens? This sigma bond is broken. Okay, it will go here, this will go here, and this will go here. This is the movement of the electrons that is shown in sigmatropic reaction. It's a reversible reaction, by the way. So the product will be, here you will have a double bond. Okay, this is the new bond, and you have a double bond here. You have a CH3 group here. So I can write here, this bond is the new sigma bond. This bond here, you can see it's in the middle of the molecule. So that's why I said that this sigma bond can be in the middle of the molecule. It can be in the middle of the molecule, or it can be at the end of the molecule, at the end of the pi system. So here I can write sigma bond is broken in the middle of the pi system. Okay, one more thing that you must recognize here. If you see, the number of pi bonds in the reactant is 2, and in the product it's also 2. So we can write the number of pi bonds remain the same. In the reactant and the product. So this is an example where I have shown that the sigma bond is broken in the middle of the pi system. Now I will give another example where the sigma bond is broken in at the end of the pi system. For that purpose, I will show you this example. This is the molecule that I am drawing it here. This is CH3 here. This is H here. You have a double bond here, and you have a double bond here. Okay. So what happens? This sigma bond is broken. It will go here, and this will go here, and this double bond will go here. It will make a sigma bond with this hydrogen. Okay, so numbering 1 1 2 3 4 5. This numbering system I will teach you in the next class. Don't confuse yourself right now. I'm going to deal with this numbering system in the next class in detail. So I can write that this sigma bond is broken at the end of the pi system. So the product will be like this. You have a double bond here, and you have a double bond here. You have a CH2 here, and this H. Additionally, you have a CH3 group here. So this sigma bond, I will write it. This sigma bond is formed at the end. So this is an example of a 1 comma 5. This is an example of a 1 comma 5 sigmatropic rearrangement, and this example indicates where sigma bond is broken at the end of the pi system.